Titrations are used to find an unknown molarity of an acid or a base. It involves the delivery of a measured volume of a solution of a known concentration called the titrant into a solution being analyzed called the analyte. The titrant is added to the analyte until exactly enough has been added to react with all the analyte, which is called the equivalence point. And what you're looking for is you're looking for a pH of 7. How do you find an equivalence point? Well, you use what we call indicators. Indicators is a substance that exhibit different colors in acids and basic solutions. Indicator paper is an example of an indicator, but it has a lot of different indicators on it, hence the different colors. Here is an example of all the different indicators that we know of. And based on where the pH lies, what color it's going to turn. So if you're in the acid range, sometimes you're going to turn red or yellow. If you're in the basic range, sometimes you're going to turn blue or violet depending on what indicator you're using. Take a look at phenolphthalein. If you're at a low pH or an acid, you are colorless. And if you're at a high pH or a basic range, you're going to turn pink. So, titrations, we're going to use this formula, Ma times Va equals Mb times Vb. The molarity of acid times the volume of acids equals molarity of base times volume of base. If we take the molarity of A times the volume of A, we get moles of A, or moles of acid. If we take the molarity of the base times the volume of the base, we get moles of B. So they equate to each other, which is the reason why the pH is 7. This formula can only be used if your titrant and analyte are strong acids and bases. Okay, you cannot use them when you're using a weak acid with a strong base or vice versa. Here's an example. In a titration, you use 100 milliliters of a 0.5 molar HCl solution. During the titration, you add 25 milliliters of NaOH that has an unknown concentration. You reach an equivalence point signified by an indicator. What is the molarity of the analyte? Well, you plug it into this equation, Ma times Va equals Mb times Vb, and we get those values, and we're solving from the molarity of the base, and the molarity of the base is 2 molar.